evaluate. Let's say that you're given this limit as x approaches 0 for x to the fourth times sine 6 divided by x to the third. So every time you're given any limit problem, the first thing you need to do is to do the direct substitution. The direct substitution means that you plug 0 for every x that you see. So in this particular case, you take the limit as x approaches 0 for x to the fourth, which is 0, and then 6 divided by 0. Notice that 6 divided by 0 is undefined. So anytime you have an undefined times 0, it just doesn't make sense. So the direct substitution for this particular case doesn't work. So you need to use another process to solve this problem. One of the processes is called the squeeze theorem. The squeeze theorem basically means that, let's say that you're given this gx, right? Whatever number the h equals to and the fx equals to, the gx will be that number because it is in the middle, and whatever h is or f is, then the gx will be that number. So that's what a squeeze theorem basically means. So in this particular case, the sine right here, the range is the sine trigonometric function graph, the range is 1 and -1. So this is the graph of the sine trigonometric function graph, and the range is 1 and -1. Once you know that, the 1 and the -1 also represents the number for the hx and the fx. So in this particular problem, the first thing that this is a particular problem, right? The first thing that we do is we use the direct substitution. And when we use the direct substitution, we know that it doesn't work because you cannot take an undefined variable times 0. So we use the squeeze theorem by using the range of it. So you set the given problem of sine 6 divided by x to the third greater than or equals to -1, less than or equals to 1. So this 1 and -1 is also a representation of the hx and the fx. So the sine 6 divided by x to the third can also represent the gx. So whatever the hx is or the fx is, the gx will be that number because it's in the middle. So once you set the range for this particular given case, the next thing is to do the multiplication. So for this, the multiplication function basically means that whatever the hx is or the fx is and the gx is, you just multiply the x to the fourth to it. So it will be like this. On the left hand side, you times -1 times x to the fourth, so it will become -x to the fourth. As for the middle case, you times x to the fourth for it. And then for the outer case, you take 1 times x to the fourth from right here. So once you do the multiplication function, the next thing is to do the outer function limit. What that means is that this is the outer function, and this is also another outer function. So you take the limit as it approaches x for it. So when you solve this problem right here, it will become 0, and this one can also become 0. So since the given case right here is greater than or equal to 0 and less than or equal to 0, so by the squeeze theorem, this given expression will become 0.